Welcome to the last video of Chapter 5, which covers vertical motion. Vertical motion is going to put together most of what we've done this chapter. You're going to set up an equation and then you're going to solve to find various aspects of things that go along with that equation. So the vertical motion equation at the top is going to be h equals negative 16t squared plus v sub 0 t plus h sub 0. So first thing that we should probably do is define what all these variables mean. H sub 0 is your initial height. V sub 0 is your initial velocity. And h is the height after a certain amount of time. So these problems are going to deal with either something being shot or something falling or something diving, and we're looking at after so many seconds, what height am I at? When am I going to be at the highest height? When am I going to hit the ground? Things like that. So if we look at the first example, it says an object is fired straight up from the top of a 150-foot tower at a velocity of 75 feet per second. So if we think about this, we're at the top of a tower, we shoot off this object, it's going to rise for a while, but then eventually it's going to start coming back down again. So it's going to be an upside down parabola. So for part A, we're going to have to write our vertical motion equation. So we're going to get h equals negative 16t squared plus, it says we have a velocity of 75, so plus 75t plus, and then we are at a 150-foot tower. So t is always going to be time, which in this case is in seconds, and then h is going to be your height after a certain amount of seconds. So for example, in B, I could ask you to predict the height after 3 seconds. So what you're going to do is you're going to plug in 3. So we have negative 16 times 3 squared plus 75 times 3, add 150. So you're going to be allowed a calculator for questions like this. So when you put this in your calculator, you get the height after 3 seconds to be 231 feet. So after 3 seconds, whatever this object is at 231 feet. So now moving on to C. At what time or times will the object be 235 feet off the ground? And then it asks us why there are 2 positive answers. So to find both of those answers, we want to know at what time, so that tells me that I'm looking for t, is the object going to be 235 feet, so that's a height, off of the ground. So using our equation, we get 235 equals negative 16 t squared, add 75t, add 150. Okay, so this is a quadratic equation. This is what we spent weeks now learning how to solve. So we have the factoring method, we have the square root method, we have completing the square. So now with all these numbers though, I'm not going to try to factor. You can, but I don't think that's going to end up well for us. We can try to complete the square, but I think honestly our best option is to do the quadratic formula. So we're going to subtract 235. When we do that, we get 0 equals negative 16 t squared, add 75 t minus 85. Now remember, you can only do the quadratic formula when your equation is set equal to 0, which is why we had to subtract the 235. Now in this case, our A is negative 16, our B is 75, and our C is negative 85. So we have the opposite of B, so negative 75 plus or minus the square root of B squared, so 75 squared, minus 4, our A is negative 16, and then our C is negative 85, and this is all over 2A, so all over 2 times negative 16. Okay, so now at this point, like I said, you're going to want to put that in your calculator, so I'm going to erase all this to give myself a little bit more room. So take out your calculator and punch this in and see what you get, please. If I start with the stuff underneath the square root, I get negative 75 plus or minus the square root of 185 all over negative 32. Okay, so now in this case, there's two answers. There's the negative 75 plus and the negative 75 minus. So first you're going to do negative 75 plus the square root of 185, and then you're going to divide that by negative 32. When you do that, you get 1 time to be 1.919 about, and then you're going to do negative 75 minus the square root of 185 divided by negative 32. And when you do that, you get the second time to be 2.769 seconds. Okay, so now the question is, why are there two answers? Well, if we think about our object, if we're currently at 150 feet and the object is shot straight up, it's going to hit 235 feet on its way up and then also on its way back down again. So that's why we get two positive answers. So now if we move on to D and E. So D says, what is the maximum height the object reaches? How long does it take for the object to reach its maximum height? Okay, so if we're talking about maximum height, if you remember from a quadratic, the maximum and the minimum always happens at the vertex. So whatever our maximum height is going to be at the vertex. So if we write our equation again, we get negative 16t squared plus 75t add 150. Now if you remember way back from the beginning of the chapter, the way to find the x-coordinate of the vertex is negative b over 2a. So in this case, negative 75 over 2 times negative 16. When I divide that, I get x to be 2.34375. Now, that can't be the maximum height. If we think about our x and our y here, or really t and h, x is time. So the maximum height is reached at 2.34375 seconds. To find what that height actually is, I'm going to have to take my x value and I'm going to have to plug it in to my equation. Sorry, almost drew it to the wrong spot. So it's going to go into this equation. So if you want to take a minute right now and try to put it in the calculator with me, I'm going to do negative 16 times 2.34375 squared plus 75 times 2.34375, add 150. So when I do that, I get my maximum height to be 237.89 feet, about. I'm rounding that. So after 2.34 seconds, our object reaches a maximum height of 237.89 feet. And what I would like you to do is circle really big the fact that you're finding the vertex. So again, this goes back to something you learned at the very beginning of the chapter, that the vertex is always going to be the maximum or the minimum. So then our very last question that we can ask is, how long does it take for the object to fall back to the ground? So if it falls back to the ground, that means that the height it's at is 0. So if we set our equation equal to 0, we're looking for the solutions or the roots or the zeros. They all mean the same thing. So again, we talked about this before. We have the square root method, completing the square, factoring. You can solve this however you would like. Again, my suggestion would be that you do the quadratic formula. So our A is negative 16, our B is 75, and our C is 150. So we're not going to get the same answers, though, that we got in part C. Because part C, we were looking for 235 feet off the ground, not ground level, so not h equals 0. So again, if we do the quadratic formula, we get opposite of b, so negative 75, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So then what I would do if I were you is I would put the numbers underneath the square root in first and figure out what that is. When I did that, I got 15,225 to be underneath the square root. And then remember, the quadratic formula is always going to give you two answers, the negative 75 plus and the negative 75 minus. So if I do the addition first, I get negative 1.512. And then I do it again, except this time I do negative 75 minus, and I divide it by negative 32. And this time I get about 6.2 seconds. Okay, now negative answer doesn't make sense. We're talking time here. So after 6.2 seconds, we say the object has fallen back to the ground. So as you can see, this is a lot of what we've done before. You're going to be doing some quadratic formula, you're going to be looking for the vertex, and then you're going to be writing an equation. Now, it's all based on how you do on this equation. If your equation is wrong, you're going to get all the answers wrong. So for the rest of the video, I have a problem that I would like you to try. If you would flip the page, please. Okay, so I want to make sure that we set this equation up correctly. So this one says, during World War I, mortars were fired from 3 feet below ground. The mortars had a velocity of 150 feet per second. So we're going to start by writing the vertical motion equation. So it's going to be h equals negative 16t squared plus, our initial velocity is 150. And then here's the part that's tricky, is it said that these mortars were fired from 3 feet below ground. So below ground means our initial height is negative 3. So this is the equation that you're going to do. I'm asking you similar questions to the previous page. So what I would like you to do right now is I want you to pause the video, and I would like you to try the rest of them on your own. This is probably going to take you about 5 or 6 minutes, so please dedicate the next 5 or 6 minutes to trying the rest of these problems. When you come back, I will give you the answer. Good luck. Okay, so hopefully you tried these on your own. I'm not going to be showing you any work. So if you come in tomorrow with all these answers written and no work, you will not be receiving credit. For part B, you should have 263 feet. So you should have put 7 seconds in for T. So then part C, at what times were the mortars 300 feet off the ground? So for this question, the height is going to be 300. So you get 300 equals negative 16t squared plus 150t minus 3. So if you move the 300 over, I get 0 equals negative 16t squared plus 150t minus 303. And at this point, you're going to have to do the quadratic formula. When you do that, you should get 2 times. You should get the first time to be 2.95 seconds, and the second one to be 6.43 seconds. So there's 2 times when the mortars are at 300 feet, 2.95 seconds, so on the way up, and then 6.43 seconds, so then back on the way down. If you didn't do that, please look at your setup for the quadratic formula. You might have made a mistake somewhere. For part D, what is the maximum height that the mortar reaches? Hopefully you remember, maximum or minimum is always going to happen at the vertex. So anytime that you find the maximum or the minimum, you should always be looking for the vertex. So this is what we did at the very beginning of the chapter. So if you do your negative b over 2a for x, you should have gotten x to be 4.6875. When you plug that in for x, you should get your y to be 348.5625 feet. So the maximum height is that 348 feet, and it happens at 4.685 seconds. And then lastly, for part E, when does the mortar fall back to the ground? So falling back to the ground would mean that our height is 0. So you should have set your original equation equal to 0. So again, this would be a case for the quadratic formula. You're going to get 2 answers. The first one is 0.020, and the second one is 9.35 seconds. That 0.020 is on the way up, though, so that's not the one we're interested in. We're interested in that 9.35 seconds. Hopefully you got those right. If you did not, please bring any questions that you have to class tomorrow. Now, before we go, there's 2 ways to approach every vertical motion problem. You can approach them algebraically as we did. So we found the maximum by hand. We used the quadratic formula to find solutions. You can also answer these questions using your calculator. There's going to be a separate optional video that you are welcome to to watch if you want to learn how to use your calculator better. If not, you can always use the algebraic methods that I showed you in the video. Again, if you have any questions, please make sure that you bring them to class tomorrow.